This is physics on simple machines. So the question reads, the figure below shows a pulley system used to lift a load of 9,600 newtons. So this one here, okay, using an effort of 2,400 newtons through a vertical distance of 20 meters. So it means the vertical distance 20 meters, then our effort is 2,400 newtons, this one. Okay, so now maybe just a background information. When we talk about a machine is any device that make work easier. So this is the pulley system. And before we proceed, in case we meet the question where they ask you to find the velocity ratio, which is VR, you just need to count the number of the ropes. So 1, 2, 3, 4, 5. So here the answer is 5. So VR will be 5. Or you can count the number of circles. 1, 2, 3, 4, 5 weeks to get the same answer. So I'll go straight to question number 1. Let me question A. So question A is saying calculate the mechanical advantage of the above pulley system. So they want us to find the mechanical advantage. So we need to know that the formula for mechanical advantage is equal to a load over effort. So this is a formula for mechanical advantage, load over effort. So just need to divide load divided by effort. So mechanical advantage is equal to, so our load here, as you can see, we have this one, which is 9,600 newtons, and over our effort, as you can see, our effort is 2,400 newton. Okay, so we'll cancel the newton and newton will cancel each other like this. So for this reason, the mechanical advantage, it doesn't have any unit because the newton and newton will cancel each other here. Okay, then from here now we divide using calculator. You say 9,600 divided by 2,400. That's our get is 4. So our mechanical advantage is equal to 4 here. This will be our final answer for this question. So I'll go to the next question, which is saying, what is the velocity ratio of the pulley system? So how do you find the velocity ratio? So we need to know that, as I said, for us to find the velocity ratio, we need to count the number of the ropes here, or the number of circles. So we have 1, 2, 3, 4, 5. So 5 circles here, or you can count these 1, 2, 3, 1, 2, 3, 4, 5. So as you can see from here, as you can see, 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. So the answer is 5. So the answer here is 5. So you say VR is equal to 5. Equal to 5, yeah, 5. So how? By counting the number of wheels or ropes. So 1, as I said, 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. So this is how you find the velocity ratio. Then now, the next question is saying we need to find what is the efficiency of the pulley system. So we need to know that efficiency is equal to mechanical advantage over velocity ratio times 100%. Okay, so efficiency is the ratio of mechanical advantage to velocity ratio multiplied by 100. So mechanical advantage, according to the question, according to the answers here for part A, is 4, and our velocity ratio is 5. So it means we're going to have to do the mechanical advantage is 4, so we get 4 here. Then the VR is 5. Then times 100%. So you just punch on the calculator and say 4 over here over 5 times 100. The answer is 8%. So So efficiency is equal to 80% as the final answer. So this will be the final answer. So question D, calculate the distance moved by the effort. So they want us to find the distance moved by effort. So I know in the question, try to read the question. Here they say that the figure below shows a pulley system used to lift a load of 9,600 newtons using an effort of this through a vertical. So this vertical distance, we call it the distance moved by load. So distance moved by load is the vertical height of 20 meters. So of the distance moved by load, it's always vertical or perpendicular. So which is what? Which is 20. So now we'll go back to the question here. So we need to say a VR is equal to a distance moved by effort over distance moved by load. So this is the formula for velocity ratio. Yeah. So our velocity ratio in trick in the question is 5 here. So 5, so it's a 5 is equal to distance moved by effort, we put x, that's what we're finding here, then over the distance moved by load, as I said, it's a perpendicular distance or the vertical distance, which is 20 meters here. So we put 20 here, then over 1, then it goes multiply here. So 1 times x, it will be x. So our x will be equal to, so 5 times 20, which is 100. So the answer is 100 meter. So this will be our distance. A distance moved by effort is equal to 100 meters. Okay, so this is the end of this question. So this is physics, a question on a simple machine. So the question reads, figure B 2.1 shows a wheel and axle for a simple machine used to lift a load of 240 newtons when an effort of 60 newton is applied. So as you can see from the diagram here, okay, as you can see from the diagram here. So the first question is saying, question A is saying, define a simple machine. So talk about a simple machine. A simple machine is a device that make work easier. So a machine is any device that make work easier. So equate to what? A simple machine. Okay, then I'll go to question B. Question B read. Calculate the mechanical advantage of the wheel and the axle shown. So they wanted to find the mechanical advantage. So how do you find the mechanical advantage? So we need to know that mechanical advantage is equal to load over effort. So this is the formula for mechanical advantage. Okay, so our mechanical advantage will be, so we need to substitute now. Our load, as you can see, is 240 here, so we put 240 here. Okay, then over our effort, as you can see, is 60 newton, so we put 60 newton here. So now we say our mechanical advantage is equal to, so we divide now using a calculator. So 240 divided by 60, so the answer is 4. So mind you, here we had the Newton here and also here Newton. So the Newton and Newton cancel each other. Therefore, mechanical advantage, it has got no SI unit, no SI unit. So the answer will be just 4. This will be the final answer. Then I'll move to question C. Question C is saying, if the radius of the wheel, big R, and an axle, small r, are 8 centimeters and 16 centimeters respectively. Okay, so determine the velocity ratio VR of the wheel and the axle. So if this type of question is given, so we need to know that the wheel and the axle, we need to know that VR is equal to a big R, big radius over the small r. So this is a formula for velocity ratio. So you divide the radius of the big wheel here over the radius of the small one here. So now from here we say we're going to write a formula here. So it's a VR is equal to, as I said, big R over the small r. So when try to make the correct substitution here, our big R, as you can see in the question, it is 8 centimeters. So we put 80, so 8 centimeters like this, and the small r is 16 centimeters. Okay, like this. You do like this. Okay. Then from here we make the division of the calculator. You say 80 divided by 16. So the answer is 5. So as you can see, centimeters and centimeter will cancel each other. So VR, it has got no SI unit. So you say VR is equal to 5 like this. So this will be a final answer for this question. Okay. Then I'll go to the last question, which is question D. Question D reads, what is the efficiency of the wheel and the axle? So we need to know that efficiency is equal to a mechanical advantage over VR times 100%, because efficiency is always expressed as percent. So mechanical advantage, the one that we have found on part B is 4, as you can see. So we're going to put a 4 here. So it's a 4 over, and VR here, VR is what? VR is 5, so put a 5 here, then times 100. So when you multiply here, you say 4 over 100, 4 over 5 times 100. Okay. So the answer that we get is 80%. So our efficiency is 8%. I hope it's very much clear here. So our efficiency is equal to 8%. Yes. The figure 2.21 shows a pulley system used to raise a load of 70 newtons when an effort of 35 newtons is used or applied. Okay, so as you can see from the diagram here. So now I'll go to the first question, which is question A. Question A reads, what is the mechanical advantage of the block and the tackle pulley system below or above, So we need to know the formula for mechanical advantage. So mechanical advantage is equal to load over effort. So this is a formula for mechanical advantage. So we say mechanical advantage is equal to, so our load, as you can see, is 70 newton. So it's a 70 newton. And our effort, the effort applied, as you can see, it's mentioned in the question to be 35 newton here. So 35 newton here. Okay, so we put 35 here. So 35 newton. Then from here now we divide 70 divided by 35, which is 2. And the newton and newton will cancel each other. So our mechanical advantage, therefore, it has no SI unit. So mechanical advantage is equal to 2 like this. Okay. So I'll go to question B. What is the velocity ratio of the pulley system? So a VR. So if this type of diagram is given in an exam, for you to find the VR velocity ratio, you just need to count the number of wheels. Example like this wheel 1, 2, 3, or the number of circles or rings. So 1, 2, 3. So the answer here is 3. Or if you want, you can count the number of ropes. So 1, 2, 3. The answer still remain 3. So we'll say VR is equal to 3. And note that the velocity ratio, it has got no SI unit as well. Just the same as mechanical advantage. Okay, so I'll go to the last question, which is saying calculate the efficiency of the pre-system. So we know that efficiency is equal to a mechanical advantage over VR, then times 100%, like this. So this is a formula for efficiency. So efficiency is equal to mechanical advantage, the one that we've calculated here is 2. So we put a 2 here. Then over the VR is 3. Put a 3 here. Then times 100%. Okay, like this. So now we multiply here on the calculator. You say 2 over 100. 2 over 3 over 3. Then times 100. The answer is 66. So we can just punch what is over here again to get the answer in decimals. So get 66.7. So first I'll write everything. So to be 6.6666667 at the end. So efficiency is equal to, so you round off this one, so to be 6.3. So since this number is above 7, so we're going to add a 1 year, so above 5, so we're going to add a 1 year, so to be what? To be 7%. So the answer is 6.7%. So the diagram below shows a ramp being used to lift a box weighing 480 newtons through a distance of 3 meters and a height of 1 meter by applying a force of 200 newtons. So the applied force, don't forget that the applied force is effort. So this is our effort. This one is our effort. So the force applied is called the effort. So according to the statement here, they're saying that the applying force, which is F of this, which means this is our effort. Then we need to know that the load is equal to the same as the weight of an object. So according to the question, they're saying that used to lift a box weighing, so which means this is our weight, and our weight is 480. Okay. Then the distance here, this perpendicular distance, is the distance moved by load, and this distance here, the distance moved by effort. So I'll go to the first question, which is saying, state the meaning of the term simple machine. So a simple machine is any device, that make work easier. So a simple machine is any device that make work easier. Okay, so I'll go to question B. Question B is saying, calculate the mechanical advantage of the ramp in figure B 3.1. So they want us to find the mechanical advantage. So as I said, a mechanical advantage is equal to load over effort. Okay, so our load here, as I said, load is same as the weight of the object. So the weight here is 480. So I put 480 here. So I say 480 Newton over the effort. The effort, I said, this is the force applied, which is 200. Which is 200 Newton. So when you divide here, what we get is 2.4. So a mechanical advantage is equal to 2.4. Remember, the Newton and Newton will cancel each other. So mechanical advantage, it has no SI unit, Then I'll go to the last question, which is saying calculate the efficiency of the ramp below. So the efficiency of the ramp, we need to know that efficiency is equal to mechanical advantage over VR times 100%. This is a formula for efficiency. Okay. Then from here now, do I have the mechanical advantage? The answer is yes, this is mechanical advantage. So mechanical advantage is 2.4. VR velocity ratio we don't have. So we need to find the velocity ratio somewhere here. So VR is equal to a distance moved by effort over distance moved by load. So as I explained, This one here, the perpendicular height, is the distance moved by load. Don't forget, the perpendicular height, this height, the vertical height, is always the distance moved by load. Then the slope one here, this distance here, the distance moved by effort. So I'll say my VR here is equal to, so distance covered by effort, as I said, is 3 meters. So I'll put 3 meters here. So I'll put 3 meters here, 3.0 meters over the distance moved by load. It will be the perpendicular distance, which is 1 meter. So which is 1.0 meter here. Okay. So my VR is equal to, my VR will be, so I'll divide now. 3 divided by 1, the answer will be 3. Don't forget that the meters and meters will cancel each other. So VR, it has no SI unit as well, just same as mechanical advantage. So I'll say mechanical advantage is 2.5 mean over 3, then times 100%. So I just need to punch this on the calculator. I'll say 2.4. I'll use this over 2.4 over 3 times 100%. What I'll get is 8%. So the answer here, so my efficiency, is equal to 80% as the final answer for this question. I hope it's very much clear. Okay, I hope it's very much clear here. Figure B 2.1 shows a wooden ladder of length 4.5 meters. So the slant height or distance is 4.5 meters. And this one, don't forget the distance moved by effort. Okay. Used to put a 900 newtons suitcase by applying a force of this one, which is 450 newtons. So the force applied will equate effort. Okay. So as you can see from the diagram, the first question is saying explain or define simple machine. So is a device that make work easier. Okay, so the device that will make work easier. Then part B, the question is saying calculate the velocity ratio of the ladder. So we know that the velocity ratio is equal to a distance moved by effort over distance moved by load. So the distance moved by effort, as you can see, is 4.5. So 4.5 meters over distance moved by load is 1.5. So this, don't forget, this is a perpendicular height. This is a perpendicular height, 1.5 meters. So I put meters here. Then we divide. So try to divide this into this on the calculator. You can punch if you want to say a 4.5 divided by 1.5. The answer is 3. So our VR automatically, will be equal to 3. It's the final answer for this question. Then you go to question C. Question C read, calculate the work done on the packaging case against gravity. So when talk about the work done against gravity, which means we're saying that a work done is equal to the force times the distance, and work done against gravity, this is same as the weight times distance, because weight is equal to mass times gravity. There's a gravity here, so it's a work done is equal to the weight given. The weight given is this one, which 900. So it's a 900. So 900 times the distance moved against gravity, or the effort distance is 4.5. So put 4.5 there. So put 4.5. So work done is equal to, so multiply 900 times 4.5. The answer is this one. Okay, in fact, there's a mistake here. The distance, since we're finding weight, and weight is equal to mg, which is mass times gravity. Then we also need to get the perpendicular height, which is the height here, because we're saying due to gravity, so get the perpendicular height. So instead of getting 4.5, the effort distance will get 1.5 meters there, which is perpendicular height. So since we're finding against gravity, so our work done, so you multiply now. You say 900 times 1.5. So the answer is 1,350. So 1,350 joules. This will be our work done against gravity. Okay, so I'll go to the last question, which is saying calculate the efficiency of the ladder. So we know that efficiency is equal to, if one can say the efficiency is equal to mechanical advantage over VR times 100%, times 100%, yeah. So the mechanical advantage according to the question here is 3, so get a 3 here. The mechanical advantage is 3, so you put a 3 here, over the VR. Now, so we find the VR, the velocity ratio. So velocity ratio, we need to know that VR is equal to distance moved by effort over distance moved by load. So our distance moved by effort is 4.5, so get 4.5 over distance moved by load is 1.5. So try to divide the answer, will get 3. So that's how this is here. Okay, made a mistake again. Sorry. So efficiency is equal to mechanical advantage over VR times 100%. Okay, so now our VR, our mechanical advantage, so we need to find mechanical advantage, and we need to know that mechanical advantage is equal to load over effort. So our load in this case, so we need to find our mechanical advantage here. So A is equal to load over effort. So mechanical advantage here is load is 900. So 900 over effort is 450. So the answer here is 2. This will be our mechanical advantage, and our VR will be 3. So I'll substitute here now. Mechanical advantage, which is 2, over VR, which is 3, then times 100. So my efficiency here I'll multiply. So I'll say 2 over 3 times 100. The answer is 66.66, which is 66.7%. But if I want, I can also use, or the other formula, I can say efficiency is equal to work output over work input times 100%. Okay, so work output over work input. So work output, so do this now here. So work output is same as work output is same as so work output is equal to load times distance moved by load, and work input is same as effort times distance moved by effort. So we try to check here. Our load there is 900. So our load is here is 900 times distance moved by load. Here, distance moved by load, it is 1.5. So we put 1.5 here. Put 1.5. Okay. Then the answer is, so we multiply 900 times 1.5. The answer is 1350. Okay, and the work done by input effort here. Our effort here, when you try to check our effort here, our effort is 450 times the distance moved by effort is 450. Okay, so it's equal to 450 times times 4.5. So the answer is this. So we multiply here again, the 450 times 4.5. 450. Sorry. 450 times 4.5. You get this value of 5 here and 5 here. So this is the work done. Work input. So now we can make substitution. Now we say here work output is what? Is 1350. Work input is 2050. Then times 2025 times 100%. Okay, so let me write it over here. So 1350 over 2025 times 100 here percent. So try to multiply this on the calculator, you get 1350 over 2025 times 100%. As you can see, we get the same answer, which is 66.7%. So efficiency is equal to 66.7%. Same answer as you can see from this one. So you can use any formula you want. Okay, I hope it's very much clear on this part. Okay. Okay.